Here we go. A lot of you guys will be very familiar. So we're done with chapter 3. We're on to chapter 4. So, here we go. Graphing. Exponential functions.
Oh, I actually know how to do this.
Oh, congratulations. You want a cookie? Whoa! Double burn on you today. Hey. Hey.
Oh, you want some cookies? Yeah, I want a cookie.
Yeah, I want a cookie. What about it? Where's the cookie? All right, here we go. That's the problem right there. I'm going to show you.
There's an X where it should be.
Okay, so first off, this is called an exponential function. Exponential functions, or graphing exponential functions, is when the variable, the x, is in the exponent. Now, these kind of equations, we're going to talk about a few of them here in a second, are like this. So if everyone can look up, actually I'll do it here so the people that are watching this, the recording, can watch. There are equations that stay relatively really flat and then rise really quick. Okay, if you guys remember this, we did this a little bit last year, those of you guys that were here. Or they stay really, really flat and then they decrease really fast. Okay, these are examples of exponential functions. Now, this is what it looks like. F of x equals 2x. The way you're going to be able to graph these is very easily. You're going to make an XY table. And I'm wondering how they're going to actually want you to graph it. They might actually have you graph it.
You place 5 dots in these.
Do they?
Yeah, it's like 4.
Okay. So they're going to ask you to place 5 dots. So the way we have to do it is we're going to pick 5x values. So we're going to pick 5x values. Now, I'm going to have you pick the exact same x values every single time. How nice is that? Okay? I'm going to have you pick those x values every single time. You're going to pick those ones because these are the easiest ones and they're going to make it so you can knock it out really quick. Okay, so now we're just going to plug those into our x. Now pay attention really closely here. If I have f of x equals 2 raised to the negative 2, if you have someone other than Andy or somebody else, if you have a negative exponent, what do you have to do?
Subtraction.
Oh, Max. Yeah, you have to flip it to make 1/4. Okay? If we have f of x equals 2 to the negative 1, you're going to flip it, which is going to make 1/2. Yeah, I know. Steve, what's 2 raised to the 0, Steve?
Something like 2. 1. Any number raised to 0 power of 1 for 0.
Any number raised to the 0 is 1. 2 raised to the 1 is 2. 2 squared is 4. Now, if you go over here to your graph, we would have negative 2 1/4, negative 1/2, 0 1, 1 2, 2 4. So your graph is going to look like this. Okay? So, today, well, we got to also talk about domain and range, but yeah. Okay. Now, the key thing about this is as follows. That's exactly how you graph it. Any questions on how you graph it first off? All you're going to do is you're going to create your table of values. Your x values are always the same. Negative 2, negative 1, 0, 1, and 2. After that, you're going to plug those values in to get x values back. Now, you're going to get some that are really weird looking, right? You're going to have a function that looks like this today. F of x equals 1/4 raised to the x. And you're going to have to punch in those functions. See what you do? See what you people do? So you're going to have some that may look like that. Nothing changes. If we have our XY table, we're going to have -1, -2, -1, 0, 1, and 2, and you're going to plug them in. Does anyone want to take a shot what -1/4 raised to the -2 is?
And you want to take a shot.
Andy? 16. What about -1?
4.
0?
1.
1?
4. 116.
How did you get it?
I just never got the graph done. Let's go.
On the last one?
Yeah.
Finally, let's say something.
So, it doesn't change anything. All you're going to do is just plug them in,
I don't want to do
and I can't.
it. Please tell me.
Tyson, I'm sorry. Tyson's just getting rang today.
20 today.
So this graph's going to look like this, and I'm just going to draw it even though it doesn't quite look like that. It's going to look like that. Now the really cool thing about these is that nothing changes. You're just going to create your x values. You're going to pick the exact same x values, -2, -1, 0, 1, and 2, and you're going to plug them in for x and get a y value back. Now we need to talk about domain and range, because this is important. Domain is always the same. So,
All real numbers.
yeah, domain is always all real numbers. Just like a parabola, domain is always all real numbers. Range is what changes again. Now, this is, I'm trying to think how I can best describe this and make it as easy as possible. Range is going to depend on what the graph looks like. Okay? The range can be y is greater than or y is less than. I don't think you'll ever see one that is y is greater than or equal to or y is less than or equal to. So your two options are as follows. Everyone get on this page? Because I'm going to turn it here.
Yeah, but it's range.
So here we go. I'm going to show you. So if you have a graph that's like this, and let's say, so there's this thing called an asymptote. An asymptote is like an invisible line. Yeah, that no graph line can go across, or nothing is inside of that. It's an empty set area. If you have a graph that looks like this above the asymptote, so it's going up, or another one that maybe looks like this, but stops shy of it, this is y is greater than. Okay, so if it's ever above the asymptote, so the asymptote's like this line right here. Well, that's in math 3 when we find asymptotes. You don't need to worry about it right now. It'll tell you, it'll have a dotted line. It'll have a dotted line, so like the ones we graphed before, stop talking, you guys got to hear this. Hey, the ones we graphed before, these have asymptotes. Does anyone want to guess where the asymptote is?
Below.
It's the x-axis.
Yeah.
So if you guys look at this, if I was this would be called the asymptote because that line, that graph line, would never cross it. So this would also be the asymptote right there. It just gets smaller and infinitely smaller. Okay, so what number goes right here? Stop. Guys. What number goes right here is the number where it crosses the y-axis. So if this thing crossed at 1, it'd be y is greater than 1. If the asymptote line crosses, wherever it crosses, it's y is greater than where the asymptote crosses the line. If our graph looked like this, if our graph looks like this, and our dotted line's right here, and one thing looks like this, whoop, it's not going to bend like that, or like this, this is y is less than wherever it crosses the y-axis. Okay? And they're always going to have an asymptote line for you. They're going to have a dotted asymptote line for you, and it's going to be able to see exactly where it crosses. The only thing you have to know is that if it's less than, if it's below it, it's less than. But of course, right? Of course it's less than. Look, it's below, it's going downward, right? So it's going to be less than. It's going upward, so it's going to be greater than. But that's it today. You're going to graph, you're going to have to list some domain and ranges.
When it's like 1/4, like how do you get 16? It's like -2.
That negative 2 goes to the top and the bottom,
So it just like.
but it causes the whole thing to flip. Yep, so it's 16 over 1.
I don't know where you got the rest of the person.
Okay, there you go.